Hi and welcome to a new video. This time we're going to talk about health bars, especially their usage in AR. But before diving into it, let's talk about health bars in general. I think everybody of you knows health bars. I just opened a HiveWorkshop page here showing you that every unit in a game, especially in RTS games, has a health bar, and this health bar should stay consistent throughout the game. So if you zoom in, it should be the same size as you zoom out. It should follow the unit and it should indicate how the health of the current unit or whatever is it. So usually the health bar in Unity is done with the world space canvas. I'm just showing you it here, but this has one big drawback. So every time when following a unit, the canvas has to be moved, has to follow the unit, and when having a few units, this could insanely drop your performance. So it would be better to have all the health bar stuff in one big canvas, and we'll do it with a ScreenSpace canvas here. And before starting, just have a look at the build settings. We added our scene, we switched to Android for our augmented reality use case. Feel free to use it in whatever game you like. In the Android settings, we switched to linear, have OpenGLES 3. GLES, have all the default settings, switched our minimum API level to 24. I'm using IL to CPP, switching to ARM64, changed the active input handling to both, and deactivated the optimized mesh data here. So that's basically the basics. The setup, the graphics settings don't apply here because we're using the default built-in render pipeline, and we're setting the quality level to medium. Vision count can be switched off. It doesn't matter for Android builds. Installing the XR plugin management for AR Core. All the default settings here will pretty much match all that you have in your project. And have a look at the package manager. Here are just the basic packages: the AR Foundation, AR Core, XR plugin, and the AR XR plugin management. Sorry about that. So we're using the device simulator here. For everyone who doesn't know about the device simulator, Unity ships with a new device simulator. You can choose different devices, have a safe area for your UI, and you can always watch how your game or your build would look on a specific device. So within this project, I will provide it via GitHub, is also the CountdownTimer component, which I introduced to you already in a YouTube short, and I will publish another short for deep links, which we will have a look another time. This time we'll focus on health bars in AR, and we're just creating an AR scene like the AR session. As you know, right click in the hierarchy, XR, AR session, and the AR session origin. I just added the AR plane manager for, I don't know, maybe having some kind of more advanced AR application. This is the AR camera default, AR camera background manager, driver, etc. The touch controls, I will explain a little bit more about them after that, which a link to our AR camera. And the most important part today, the ScreenSpace camera canvas, which can be added via right-click UI canvas, and the setting of the render mode will be changed to ScreenSpace camera, and the render camera will be our AR camera. Please note that very important, the plane distance is smaller than the far clipping plane of our AR camera. Just have a look. If this clipping space, the plane distance will be changed, and as you see, as soon as the plane distance is bigger than a far clipping plane of the camera, it will disappear and will not be rendered. So that, please keep in mind that this value is always at a lower value. I'll just keep it with 15 here. You can also change it to 99, but as soon as it reaches 20, it will disappear. So make sure to leave it at 15, 16, or whatever. And within this ScreenSpace canvas, which is linked to AR camera, there is just an empty game object, enemy health bars, and within these enemy health bars there are two health bar objects, which consist of a normal rect transform, a health bar component. We'll have a look at that in a minute, a red color image, simply red color image, and as a second child a green color image. Second health bar does look the same, and if you wonder why there is a red and a green color image, Unity draws all of its UI beginning from top to bottom. I'll just move the second health bar over here so that we can see that there are really two health bars, and as soon as the second child will be moved to the first place, you see that the red color image is visible, and if we again switch them, the green color image is visible because the red color image is drawn first. So changing the green color image to filled, horizontal and left, you see that we can control the fill amount of the image with the slider here and simulate some kind of health bar. So with a proper image and everything else, this will look like a health bar and will work like a health bar when changing the fill amount. And we'll do that in this short tutorial. The next object is the event system. Well, it's a basic event system and just a small cube, moved a little bit to the left or to the right and to the right with an enemy component, so they will just be placed within our space and in augmented reality about 2 meters in front and 1 meter in height. And these enemy cubes are linked to the enemy health bar, so every enemy cube has its own health bar and the other way around. And I guess it's time we'll just look into the code. We'll start with the enemy class, which has the minimum health here at constant at 0 with the maximum health with which can be changed, the current health just for indication, and damage per hit, which can also be changed in the inspector, and a reference to a health bar. When starting our application, we're just setting the current health to max health, like spawning an enemy, and in the update method we'll just check if our enemy is not dead, and if he is dead, so the current health is lower or the same at the minimum health, we'll just deactivate it. Again, you can use pooling here or any other mechanism. I'll just try to keep it as simple as possible. And there's a public method which will apply damage and also notify the health bar that there was some damage dealt to our enemy, and we'll just log something in the console so that the enemy and its current health can be viewed from the developer side. And as we see here, there is the macro health, current health, damage per hit, and the reference to health bar. And the health bar has also its own component, which is a little bit more complicated. So there is a reference to our AR camera, the ScreenSpace canvas, our health bar green and red. This could be solved way better here, but just for simplification reasons I'll leave it like this, and our enemy game object. The private variables are just the enemy game object renderer for visibility and our rect transform, which will change the position for our health bar, which is basically the rect transform where the component is on. And with a reference to our AR camera here, the ScreenSpace camera canvas, the green color image, which is a child of our component, the red color image, also a child of our component, and the enemy, which this health bar belongs to, indicated by numbers in this case. And again, starting with the start method, just getting the rect transform component for positioning, the fill amount of the green image for resetting the health bar, and our game object renderer of the enemy game object. So now we're just in the update method and looking if this enemy is visible to our camera. And when looking at the documentation, just switching here, it is, the renderer is visible, and note that this may say visible to any camera, and it really means any camera. So although the documentation states a few things here, even when it's not visible to the camera, but it's still needed for other reasons, it will be visible. And when running in the editor, the scene view cameras also count here and will keep it visible. Okay, it's visible, so we're switching everything to enabled. That's not, it could be solved better too, but yeah. And for repositioning, the let's say old way would be to use the world to viewpoint method from our camera with a new position of our health bar, and calculate everything like the viewport position of our ScreenSpace canvas and so far and so forth, and then use the anchored position to reposition it. I'll decided to go with a little easier version here to first determine the health bar position, which is basically the position of the enemy game object, but about half a meter above, and then use the rect transform utility from Unity to get the world object screen point, which will have a camera and a health bar position as parameters. And the funny thing about this method is that this is not documented at the Unity documentation. As you see here, the rect transform utility does not contain this method in an official way, but it's here and it's working, and it's basically working the same way as the camera world to screen point does. So this would also be a possibility to save it here, which transforms the position from world space into screen space. The documentation is pretty clear on how the position is calculated, and as the last step to get it really for our screen space would be to use the screen point to local point in rectangle method to just tell Unity, okay, I now have the screen space position, but in my local point rectangle, where is this position located here? And we'll get a local point, a vector 2. Please make sure to not use it in some kind of if statement or something like this, because this always returns true. And in our case, the parameters are the screen space canvas, the world object screen point, the DAR camera, and our world object screen position, which will be the anchored position for our health bar. And as long as this is visible, this is changed, and if it's not visible anymore, we'll just disable it so that the health bar is no longer visible. And again, there's a public method for applying damage to just reduce the fill amount of our green health bar, which will be called as soon as damage is applied or dealt to our enemy. Here we go. Enemy cube is linked. Here are all the links. Just checking again, and we haven't talked about the touch controls. Again, the touch control of the simulator is not possible to do multi-touch, only single touch, and I use a method of the old input system here. I just check every frame if the touch count is bigger than 0, if the touch phase is touch begin, and then cast a ray from my AR camera to the world, checking if the physics raycast intersects and if the hit object name contains enemy, and if that's the case, I'll just get the component for enemy and apply damage here on touch. I log something, and that's basically it. And that's a very short but efficient way to display health bars, and we'll try it in the editor now, switching from the game view to the simulator. And as you see, the cubes, as soon as I move them, the health bar will follow. I'm just checking here in the scene view. Okay, as soon as the cameras are, if it's not visible to the cameras, they disappear. You see that this may not work the way you intended to, but trust me, on the device it's working. And as we see here on the left side, as soon as the cube comes in, the health bar is visible again. Here we go. And it's following, basically. As you see here in the documentation, scene view cameras will also cause this value to be true. Okay, fine by me, gotta say. And I'm just moving the cube here forth and back, rotating it a little bit, and the health bar will always stay the same. Here we go. And as soon as I click on my cube, you see the debug log messages here, the health bar will decrease and the objects will disappear. Wow. So that's basically the best way to do it. In a performance efficient way, you can also use pools for everything, and I'll just now show you how it looks on my mobile device. Here we go. Here is the cube, another cube. It's placed in the room so it will not move because we're using AR core, and you see me tapping around, nothing happens, and as soon as I tap the cube, the health is decreased, and as it reaches 0, it disappears. And the same goes for this one here. Tap, 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 and here we go. Nice. So thank you for watching. The link for the GitHub repo is in the description box, and hope to see you in the next video. Bye.